Okay, Alex, so let's start with this one. You were really close, except you circled the 4 or the x minus 7. So remember, terms are separated by plus and minus signs. So here's a plus sign, and here's a minus sign. That means the x is a term, and the 7 is a different term. So when you're circling like terms, you actually would just circle the x and the 4x. And the 7 is going to actually go by itself. It's just a coefficient. And I think that's where you went wrong. So let's see. Then, and let me get a different color, you would combine 4x squared with 3x squared, and both of those are positive. The sign right here in front of the 3 is a plus. Oh, actually, looking at the original problem, it's a minus. Okay, it looks like it's a plus, but it's a minus. So, get my little pen. Oh, there it is. So we're going to have 7x squared, or excuse me, 1x squared. So it's a positive 4x squared and a minus 3x squared, which would be a positive 1. 4 minus 3. So that's what looks more like a 1. And you can actually even just write x squared. Okay, so we're going to write x squared for the two orange terms. Now we'll combine the red terms. So you have a positive x and a positive 4x. So 4 plus 1 would give you 5x, so plus 5x. And then plus 7, actually minus 7, it's a minus sign in there. Minus right there. So minus 7 at the end. And then it would be all over your common denominator, which you already did that part, x squared minus 7. So that would be your final answer, and that does match with option C. Okay, so let's take a look at question 2. Okay, so we have 6a squared minus 7a plus 8. And you realize, okay, they have a common denominator. You put everything in the numerator. That's perfect. Okay, let's take a look at your terms. You're right. 6a squared and minus a squared are like terms. The tricky part here is the minus sign. The minus in between this first rational expression and the second rational expression, it's actually like a minus 1 that needs to be distributed to the entire second fraction. So you actually want to make sure you can kind of like write parentheses around the top of that numerator and distribute this negative 1 out here to everything inside. And that was really the tricky part there. You looks like you identified all of your like terms correctly, so you should be good from there. So let's try to fix it and see what happens. So we'd have 6a squared minus 7a plus 8. And then here, if we do minus 1 times a squared, we'd have minus a squared. Then we're going to take minus 1 and multiply it by minus 4a, which would make it plus 4a. And then minus 1 times positive 6 is minus 6. And then all over 2a minus 1. Okay, so now, let's grab our color coding. We would have, I lost my, here we go, 6a squared and minus a squared. That would give us 5a squared. Okay, and then we'd have minus 7a plus 4a, which would be minus 3a. And then we'd have positive 8 minus 6, which would be positive 2. And then all over 2a minus 1. So option D was the answer there. Okay, so actually that should help you for question 3. It's the same thing. There's that minus sign there. So you really want to put parentheses around the numerator and distribute the negative. So basically it just changes all your signs. Except for the first one. I mean, if you do negative 1 times 8n cubed, you get minus 8n cubed. But this actually would be minus 2n squared plus 4n. So other than that, looks good. It looks like you put the right terms together from there. Okay, let's take a look at question 4. Okay, you did multiply the first fraction by x plus 6 on top and bottom. That's perfect. However, you got to be careful. You actually are going to have to change this fraction as well. So look in the denominator. If you multiply x plus 6 times x plus 1, in this denominator, or in this fraction, let's write what you'd have over here. You'd have 3x times x plus 6. Okay, so that's 3x, x plus 6. And then in the denominator, you have x plus 6 times x plus 1. Okay, so let's check and see, because in order to put these together by subtracting, you have to have a common denominator, right? So if you look at the denominator here, it still doesn't match this one. This one has an extra x plus 1. So in order to get it combined with this one, we have to multiply this fraction by x plus 1 on top and bottom. So we actually would take the opposite thing and multiply it by each fraction. So I'm going to write out what we have here. So we have minus times x plus 5, x plus 1, all over x plus 6 times x plus 1. Okay, so now what we want to be careful of, and this one's a tricky one. I know in Class Connect I was saying to keep everything factored, and this really just takes some practice to know when to leave it factored and when not to leave it factored. In this case, what I'm going to do, just because I might be able to, if I FOIL this out, in other words, unfactor it, I might be able to have some like terms here that would combine with the like terms here, and then I might be able to factor it again to get some stuff to cancel with the denominator. So what I'm going to do is I'm going to FOIL this out, and then I'll distribute this minus sign. So you could think of it as first, outer, inner, last. I like to just think of it as a face. So I don't know if you can see the face or not, but these are the ears, and then these are the eyebrows, and this is the nose, and this is the mouth, and then these are like the eyes right here. So you can think of first, outer, inner, last, FOIL, but if you do, think of the face, it'll get you to the same spot. So x times x is x squared. 5 times 1 is 5, and we usually write the term without a letter at the end. And then we have a positive 5x and an x times 1, which is a positive 1x, or just an x. And then I'm going to combine those middle terms. They're like terms. So I would get x squared plus 6x plus 5. Okay? And then remember, there you want to put that in parentheses, and remember to distribute that negative 1 all the way through, like that. Okay, so, and then in this first one, I'm also just going to unfactor it, just because you know that there might be some factors. Sorry, there might be some factors that you can combine if you do that. So we're going to do 3x times x, so that would give us 3x squared plus 18x. So 3x times x is where I'm getting the 3x squared. Positive 6 times 3x gives us plus 18x. Okay. Then we have minus 1 times x squared minus x squared minus times positive 6x would be minus 6x, and then minus times 5 would be minus 5, all over x plus 6 times x plus 1. Now you just want to combine like terms. Okay, so we have 3x squared and minus 1x squared. So that will give us 2x squared. Then positive 18x minus 6x would be positive 12x, and then minus 5 at the end. And then you can just check those terms to see if it would factor. First, check and see if there's a GCF. There's not going to be. There's not a number. 2 and 12 are even, and 5 is an odd prime number, so nothing's going to factor out of those. You could also see if it would FOIL, like backwards FOIL, but that is not going to work either. So you actually would just leave the top like that, but you just check and make sure that you can't factor it. But that will match with option B. And another way, I know up here I was saying, okay, now I know to FOIL this out and distribute this negative. And you're thinking, oh, great, well, that's nice that Mrs. Williams knows that, but how am I going to know that? Well, then one nice thing is you do have the multiple choice options. So even if, at this step you didn't FOIL this out, and you just put 3x times x plus 6 minus x plus 5 times x minus 1 all together in your numerator and just left it like that, that is actually correct, but you would look at your answers and you'd be like, that doesn't match any of those. So then that would be a clue to you to go ahead and FOIL this out and combine like terms like we did right here, and then it should match. So you kind of just have to play around with it, but another key reason that I knew to do that is that you don't want to leave, okay, so like, it's factored if all that's left is stuff that's being multiplied. So if you have, this times this, times this, so like say you had, x minus 1 times x plus 5 times 2x squared minus 2, all of this stuff that's left, if that's where the problem ended up, all of that is being multiplied. Here, if you had left it, there would be a minus sign in between these parentheses, and that indicates that they're not being multiplied. Those are two separate terms. So that's another clue as well, that you want to actually unfoil it and combine like terms. So like I said, it just kind of takes some practice as well. But I hope that helps. That problem should help you with problem 5. Problem 5 is actually not quite as hard as problem 4. All you have to do is take the second rational fraction and multiply the top and the bottom by b minus 2. But from there it would be the same. You would get something that looks like this, and you'd actually want to go ahead and FOIL things out in the numerator and combine like terms. So let me know if you have questions from there.